Hello, people. We are back with another podcast, and this time we have a special guest with us, who is Vivek, who is working with us, but in spare time does a lot of fun electronics projects as a hobby. And you can see in the background he has a very nice lab setup. So hello, Vivek, and I think I'll give major reins to Rajat and Vivek. They have planned a special project to discuss in today, and yeah, over to you, Rajat. Let's take it from here.
Yeah. So just to set up the context, Vivek works with me, and I came. So we were talking, and I came. He was showing me one of the demos that he was planning, and I found it really cool. And he will go into much more details of the demo, but he was showing me all his about his YouTube channel, how he has been building side projects since his college days, and these are really cool. And so he recently did a project that that teaches a lot about physics, and that's why he's here to talk about that. So why don't you give us an intro about yourself, Vivek?
And
Yeah,
yeah, guys, I would also recommend to check out his YouTube channel. Link will be in the description. So it's awesome, full of all of these fun side projects which teach you a lot. So yeah, do check it out. Over to you, Vivek.
yeah. First of all, thank you for inviting me to this podcast. Uh, and First of all, I will introduce myself. I am Vivekanand. I completed BTech in 2017 from Pune, 𝐂𝐵 Pune. Then I worked in Wipro as a ASIC verification engineer. Uh, then I left that job mm, and then completed masters in solid state devices from IIT Bombay.
Nice.
And then in 2022 I joined Micron as a firmware engineer.
Hmm.
And this April I joined Google. The electronics was my hobby since childhood. But after coming to engineering, I started actually studying it. From first year only, mm, when when I saw the Arduino,
Hmm.
my interest developed in the
Hmm.
embedded side. And from Arduino, then after using Arduino, I I started using 𝐷𝗵𝗽𝗀 standard.
Hmm.
Uh, I designed PCB for that,
Hmm.
and then I jumped to STM32.
Right.
Started when then I started using STM32. Then mm, then I was in search of a microcontroller with wireless functionality.
Hmm.
For STM32, I was using external Bluetooth module for displaying real-time data on the computer. So it was increasing the size of the module.
Okay.
So for making the miniature modules like 𝐁𝗵𝗽𝗀, I was in search of controller plus inbuilt wireless functionality. So
Hmm.
I shifted to ESP32.
Yes, Peter. Yeah.
But when I saw ESP32, there are modules available in market with ready-made antenna and
Hmm.
chip holder on it. Uh, s- so if I use ready-made module, then I can't minimize the size of PCB. And if you want to do physics experiments,
Hmm.
module must be as small as possible. Ideally, it should be a point, but practically it
Ah, I
should
see.
be,
Okay.
yeah.
Hmm.
Uh,
So you basically, and that is required because you want to stick that miniaturized module right on the object, which is
yeah,
our sort of the system, physical system, which we
yeah,
want to track and do experiments on, right? Is that correct?
yes,
Oh.
yes. And
So why don't you show that miniature device to the guys?
uh,
Hmm.
so
This is amazing.
This looks like a watch dial, but man, it's all made by you.
yes, yes.
That's
Uh,
interesting. Really
so
nice.
and this is another one. Means
Okay.
are same, but
Hmm.
I stick it on the carom striker because I
Oh
want
wow, wow.
Wow.
because
And
I
guys,
want
I am
to.
really like all the tools behind you sort of enable you to do that, right?
Yes, yes, yes. I
Uh,
will.
So you did
Hmm.
everything: the PCB design, the component, choosing which component to put in, the
Yes,
signal integrity analysis, etc.
yes, yes, yes.
That's amazing.
I will
and
explain
it's
what.
you are an inspiration. And I'll tell you first, your Arduino thing sounds really relatable because this is exactly how I also got interested in embedded.
Yes.
Second year Arduino, LED blinking, and it kind of
Hmm.
kind of spiked my interest towards embedded. But then
Yeah.
that's ESP32. That's it. Like that's where I have stopped myself. But you have gone like
Hmm.
levels and levels deep into
Yeah.
PCB design, into man, it's crazy. I don't even know half of the stuff, like the names of half of the stuff which you have actually gone and ventured and done this. So really kudos to you.
Thank
And
you.
we should definitely discuss more on this. Yeah.
Yeah.
Go
Yeah.
ahead.
Sure. So, uh, so, so instead of using the ready-made module of ESP32,
Hmm.
that module only contain the minimal circuitry required for the controller around
Hmm.
it and antenna.
Hmm.
Designing the antenna is most difficult part,
Hmm.
because at means antenna this antenna carries Wi-Fi signals, means it's 2.4 gigahertz.
Right.
So at this frequency, uh, designing PCB means the layer between two paths, means top
Hmm.
and bottom, that also conducts at this frequency.
Hmm.
Yeah.
For low frequency, we assume that space between two layers does not conduct.
Hmm.
But at RF frequency, we need to consider that
Hmm.
its impedance become comparable with the
Hmm.
components we actually use. So first PCB failed because I did not have
Hmm.
any experience with RF PCB design.
Hmm.
Then one of the channel on YouTube, that is Phil's Lab, uh, that tells how to design RF PCBs. I referred that and then made this PCB, second PCB.
Mm, RF is one of the things I never understood. I never understood the concept of moving into spherical
Hmm.
coordinates, into cylindrical coordinates, the
there is a
terminations,
there is a line,
etc.
right? Everything becomes a capacitor when you increase the frequency. That's
The,
and probably
Uh,
the only thing
yeah,
I remember from RF world is this right hand rule. That's all.
yeah. So,
interesting. Okay. So
yeah.
how do you want to pursue forward now, Vivek? Do you want us to introduce, or rather, do you want to introduce what you are working on, what project you have in mind, and what you want to share there?
Mm, yeah. Shall I tell my previous projects or this?
Anything, Rajat? Like, do you want us
I,
to
I
treat it
think
like
we
a
can talk
journey?
about this. I think we can.
Okay.
This sounds interesting.
Mm-hmm.
Let's talk about that miniature thing more.
Hmm.
I'm more interested in talking about that.
Okay.
So you must have some accelerometer or sensor over there as well, right? Accelerometer
Yes,
or
yes,
gyrometer.
yes, yes, yes. I can. Means how can I show you? At the center, I mount it correctly at the center,
Hmm.
Okay.
because
Nice. Nice.
when there is a
Hmm.
rotational motion, then it should be purely rotational motion for that sensor. So it should be exactly at the center.
Hmm.
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 Yeah, because
Then
calibrating and sensor fusing all these sensors on a board is again itself a challenge.
Hmm.
Mhm.
How you calibrate these sensors to give you the right values? Else, the
Uh,
accelerometer and gyro sensors can give you some random values if not calibrated correctly.
yeah, yeah. Calibration is just getting the offset.
Yes.
So each according to the their how it is after manufacturing, every I'm share on my screen. I'm sharing the 3D model of that. Okay. So calibration means getting that offset. For getting that offset, first we need to read lot of means for 1 second read about 100 values,
Hmm.
and that then get mean of that.
Okay.
Yeah, and uh, while calibrating, we use acceleration due to gravity. The only known means standard available acceleration currently acting on all of us is 9.8 meter per
Mm-hmm.
second
Yes.
square. So if we keep module like this,
Mm-hmm.
then uh, then this is x-axis, this is y-axis, and this
Mm-hmm.
is z-axis. Currently, acceleration only acceleration acting on it is 9.8 in downward direction
Mm-hmm.
In the z-axis.
in the z-axis.
Okay.
So we need, so the z-axis will show some reading, and that reading is equal to 9 point. That reading is calibrated to 9.8 meter per
Hmm.
second square.
So basically, we take that as a reference and then calibrate every other readings, taking
Yes.
that as a reference. Okay.
Yeah.
So it becomes exactly like calibrating the low offsets of the ADC, etc. You join ADC, connect ADC to the zero, and then see what's the value ADC reads, so that you can offset
Mm.
the lower one. So there is
Yeah.
the offset error. What about the gain error? Do we have something like gain error? I know ADCs have a gain error where they
Mhm.
don't gain corresponding to the voltage. So there is a gain error that you have to compensate as well to get the correct values. Do accelerometers also have that kind of problem?
Uh, I did not observe that, but once we get offset, for example, we got offset of 100. Mm, so if this is the 16-bit accelerometer,
Mm-hmm.
16,
Okay.
16 bit, and it gives two complement of the reading, so positive and negative values.
Hmm.
Hmm. So and if it's full scale, it can be adjusted to two plus. It can be configured to measure plus minus 2g for full scale. Plus minus 2g means
2G. Okay.
yeah,
Okay.
Twice the acceleration of
Whereas
gravity.
it can be acceleration in the negative as well as
Negative.
positive, so it
negative
becomes
as well as
Upward,
positive.
downward.
up and
Yeah,
down.
up and down. So this is the 16-bit accelerometer. So mm, uh, 2 raised to 15 upward, 2 raised to 15 downward, positive and negative
Mm-hmm.
values.
Mm-hmm.
So this full all numbers are divided is it will give maximum for plus maximum is around plus 32k, around plus 32k
Mm-hmm. Right. Right.
for plus 2g, and minus 32k
Hmm. For negative
for
of
minus,
2G.
yeah. So
So
this full scale is divided.
understood.
Okay.
And I think personally for me, I have never seen your project before. So, and I think for audience as well, can we show like what this project does and the outcome of it, and then maybe we can wrap our
Yeah.
story around it.
Yeah. Can I share my screen?
Yeah,
Or
Yes,
sure.
yes,
Go ahead.
yes.
okay, I will show you the demo. Mm, Pyjama.
In
Okay.
the meantime, you bring it up. How organized are you? I see your watch hanging along with keys.
Yes.
Yeah.
I was just
No.
joking the moment that my home lab set home desk is more cleaner than my office
Office
desk,
desk.
which is being cleaned by some other person.
It is. It is just because of this podcast. Otherwise, everything is messy. Yeah. This is second screen share.
This is
Okay.
awesome. Yes.
Mm, I have shared second screen. Can you add that?
Yeah. Yes, I
Mm,
will. I will put it in. Yeah, we have it.
Nice.
so this is the program.
Hmm. Mm-hmm.
Yeah. Uh, I turn on the module, and then
Okay.
connection lost. I'm seeing connection lost. Is it? Mhm. Yeah, it is lagging. It is lagging. Mm, Currently, I am. I think we can't. Currently, I am connected to my 5G Wi-Fi, and this module can connect with 2.4G only.
Okay.
For
Okay.
So
I
Okay.
I
see.
think.
Mm-hmm.
Hmm. Yes. But how can I show you now? Because this module connect with my home Wi-Fi
Mm-hmm.
to same home Wi-Fi has two Wi-Fi's, 2.4 gigahertz and 5
Two
gigahertz.
channels. Uh-huh.
Yeah.
Mm-hmm.
So now we are connected to 5G. Wait, I try.
So we
Shall I
have to be
try
on the
switching
same
to
network.
other Wi-Fi?
Sure,
Yeah,
sure. I
we have to
Sure.
be
think
on
it
same
should
network.
work. Hopefully.
Yeah. Hopefully, we should be able to keep
Hmm.
up with the bandwidth.
Yeah, I
Yeah.
mean, there
Shall
might
I
be some
switch to
lag
other
on.
Wi-Fi?
Yeah, yeah. Go ahead. Go ahead.
Go
Go
ahead.
ahead, Vivek.
Yeah. Yeah. Mm,
Okay.
so I started now, and yeah, EVP server is
Mm-hmm.
created, and this is the this is the address. This is the computer address, and this is the address of Electrofy connected.
Mm-hmm.
Okay.
Uh, so, hmm. And this is the graph. Now I am sending. We want acceleration, so I am sending this command to uh, our module
I
control
see.
control. Hmm. Send. Okay. So now here we can see the real time plot. Three. So can we show camera also so I can show
Yes.
the movement
Mm-hmm.
Yes.
as
Yes.
well
Yes. You
as
can show the camera.
reading. Okay, I'm turning on the camera. Okay. Uh, can you? Okay. Now I'm moving it in the Z direction. Z is I
Mm-hmm.
think mm, Z at Z you can see 9.8. It's below.
Yeah, it's around the blue line
Hmm.
you are showing.
And
Yeah. Blue line is
and
9.8. So
9.8.
when he doesn't move it,
hmm.
it stays at
It's
9.8.
Yeah.
mm-hmm.
Now I rested it on the table. Now
Hmm.
stable it is
It's
9.8.
9.8. Yes, yes.
Yeah. Now I'm lifting it and
Mm-hmm.
oscillating in the vertical direction.
Mm-hmm. So
So
I can
Z
clearly, we
axis.
can clearly see the oscillating curve there of
Yeah.
acceleration. Yes.
Yeah. Now here we'll show. Here you can see I have marked X, Y, and Z axis here.
Mm-hmm. Right, right, right. Hmm.
Yeah, Z here it is coming
Hmm.
out,
Correct, correct.
and
Coming
this is
out to
X
our
axis.
screen. Yes.
Yeah,
Yes.
yeah. Yeah, from back side, this is Y, X, and
Mm-hmm.
it is going inside.
Hmm. Hmm.
Okay.
Yeah. Now I will oscillate in the X direction. X
Hmm.
is I think red one,
Hmm. Hmm. Hmm.
and Y.
Okay.
Y. Y is green one.
Y is
Okay.
green.
Hmm.
Yeah. Uh,
Vivek, can you again put the device on the table? Just 1 second. I want to see you know, the stable
hmm,
state graph. And here I
yeah.
see 9.8 blue. And
yeah.
the green and red are like way down. They are not zero as well. So
They so it is because of this screen. When I pull it to my other screen, means uh, this is different. This is 2K screen. But if I drag it to my laptop screen, then
oh, I see, I see. You are
it will
saying
It's a
get
scaling
it's
issue
a
of the library.
means
basically a
it is,
rendering issue, huh? Not
yeah,
a
rendering
rendering
issue. This
issue.
is
Okay,
library rendering issue. Yeah.
I see, I see.
Uh,
Yeah,
Okay,
so
got it.
that explains why we don't see the Y graph as well below zero.
The line is cut. You are saying.
The line is cut
Hmm.
between X and
Okay,
Y
okay.
axis.
Yeah, yeah, yeah. Rendering.
Yeah, it is rendering issue for this screen. If I
Hmm.
share my this screen, laptop screen,
Hmm.
it will show zero.
It
It
will
is.
show. I see, I see. Got
Yeah.
it, got it.
Okay.
Awesome. And also one more
Also,
question. Do you like? Can you tell us why did you have to send that command? MPU send acceleration gyro C. What does that do?
yeah. So this accelerometer, means this is not just accelerometer. This is IMU. IMU means it can send accelerometer data plus gyroscope data.
Inertial
Yes,
measurement unit. You mean?
magnetometer data.
Hmm.
Yeah, inertial
Hmm.
motion measurement unit.
Hmm.
So inertial measurement unit.
Hmm.
Yeah. So it can send temperature, three-axis
I see.
acceleration,
Three X.
three-axis gyroscope data,
Hmm.
and magnetometer data.
Hmm.
So for real time, we may need less data. So to avoid the delay,
Ah, I see.
so
I see. I see.
I made this command line
Nice, nice.
for this.
So guys, we had the demo, and basically Vivek has made a miniaturized device which is like a tag which you can wear, and it will give you all your inertial measurement data depending on what you select. So which is pretty cool. And the awesome part is that you have been able to do that not buying a PCB, but you have basically essentially designed the PCB yourself. Just bought the ICs, right?
Yes.
That's really cool, man. That's really
Yeah.
awesome. And plus it emits the data wirelessly. That's a very key and important thing. You will not, I don't think we will find any like ready-made solutions for that, right?
Yeah.
Yeah.
Awesome,
Hmm.
awesome. I'm
Yeah.
really,
Wireless is required because hmm, for
you
physics
want it to be
experiment,
free.
wire.
Exactly.
Yeah,
Yeah,
it
yeah, yeah.
should be free.
Hmm. Awesome, awesome.
Yeah. I think
So,
what we can do is so Vivek has a video where he explains the complete demo. He has recorded that. We'll share the link of that video so that people
hmm.
can go and look at the complete demo.
Yeah.
Yeah, definitely, definitely. I mean, I'm gonna go and do that personally. It's just
So
a
I think in the meantime, Vivek, what I would be interested in, why don't you show the 3D diagram, the pendulum that you designed? I think we can see the pendulum.
hmm.
Yeah. Yeah. So I designed this. Means it does not have just pendulum.
Hmm.
It is designed for circular motion also. Means
Oh, okay.
now
It
it
can
is
go full
pendulum.
round. Hmm.
Yeah. Also, it has here it has a motor.
I see. Okay. Hmm.
Here it has a motor
Hmm.
for, and it get connected with some adapter. It get connected
Hmm.
here, and it can do vertical motion,
Hmm. Hmm.
vertical circular motion. And if it placed like this, it can do horizontal circular motion.
Hmm.
Uh, yeah,
And what is the idea
and
behind this device?
uh,
We are
means it
measuring
is a
something like.
fixture. Yeah, this is for this our electrophy module get attached with
I see,
here.
man. Okay, okay, okay. And
Hmm.
you want to basically, so let me sort of, like paint my picture what I understand. You'll connect your model. You will
Hmm.
basically track the accelerations in all three directions and make sure
Hmm.
that it sort of fits the physical analysis, the physical
Yeah, yeah.
predictions. Oh, nice, man.
So
Nice.
using this, we can
Hmm.
measure the centrifugal
Hmm.
force.
Hmm. Hmm. Hmm.
Centrifugal
Awesome.
uh,
Awesome.
in vertical, in horizontal, it is constant.
Hmm.
In
Hmm. Hmm.
vertical,
Hmm. Hmm.
G gets added.
Yeah, 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 yeah. Awesome. Awesome.
Uh,
It's very
so
cool.
it
Have
has
you done this? Have you done this, or you are in
no,
process?
Yeah, I'm
in
doing
process? Okay.
experiments. Yeah,
Okay, okay.
He has done
Keep
the
me.
pendulum one,
Okay,
pendulum.
the
pendulum.
oscillations of the pendulum.
Mm-hmm.
Yeah, yeah, simple harmonic
That's the
motion.
demo I was talking about that he has done and
I
published on
see.
his
Okay,
YouTube channel.
okay, okay, okay. Man, I'm gonna go look at this. And sorry, I did not come prepared. Actually, I
Yeah,
just knew
it's
Rajat
okay.
is gonna invite Vivek. I
Yeah,
did not have like much background or what, but I'm
yeah.
really really impressed, man. I really
Thank you.
speaking from the heart, and I really hope our audience also kind of their spirits were also kindled as to what
Yeah,
you can
sure.
achieve like just by this setup. Like I mean, obviously it goes a lot, but it provides everyone with the inspiration that it's possible. It's possible to
Mm.
design PCBs at home and get this much precision and with such cleanliness, I should say. Yeah.
Yeah. So all I want to say is that continuously people ask, okay, I have learned C, I have learned this, I have learned this. Okay, I do at office, but what should I do next? Well, I
Mm.
say if you look at Vivek, you are just restricted by your inspiration and what you can imagine.
Mm.
Hmm.
If you want to do something, you have things that and you just do things you want. You know
Mm.
electronics.
Yeah,
Yeah, passion. Just follow your
Yeah.
passion in
yeah.
the direction which it takes you in. Awesome, awesome. Rajat, personally speaking, and I think you would also agree, let's invite Vivek over for more of such podcasts, and
But
whenever he's working.
I want him to in one postcard just go through each of his racks
Hmm.
and tell us what all he has in his
Yeah,
lab.
yeah, sure.
Sure, sure. Yeah, let's do that. Yeah.
Yeah.
There are
I've
so
not
many
seen
cute
these
little
many
boxes.
equipment since my
Yeah.
last company.
Yeah. So Vivek,
Mm.
before we wind up, I want to like ask you about your journey. How did you sort of go about like, hey, I want to design a PCB, and it's totally possible. Let me just invest obviously money and your time and effort. But then,
Mm.
what sort of inspired you to do that?
Means, PCB I designed here, but manufactured it from outside.
Right, right. You
Yeah,
basically give them the design source, right?
the yeah Gerber
Hmm.
we give them.
Hmm.
So I learned it means designing. I learned it in while I was in BTech. I was
Hmm.
a part of a technical club called Baha, in which I
I
was
see.
we were designing a all-terrain vehicle, and
Hmm.
there was competition at Indore.
Hmm.
Uh, it means students from different colleges come there,
Hmm.
and there was racing. Yeah, I was a part of data acquisition subsystem. Uh,
Ah, okay,
so
okay. Hmm.
for 4 years, I was part of
Hmm.
that club. So in that vehicle, in that car, I was needed to attach some sensors and get data, then
Hmm.
analyze that data. uh, at that time, I learned means I learned this PCB designing
Hmm.
and embedded systems.
Hmm.
Yes. And then at that time only, uh, I wanted to set up such lab.
Hmm.
But after getting job, I
Hmm.
set up this. Yeah.
Right, right.
And
It's
then
basically,
during
every engineer's fantasy somewhere they want to set up lab. You have basically achieved it. So.
Yeah, and I set up this lab during lockdown.
Hmm.
Lockdown, in my I was pursuing the MTech, but after lockdown, I was free for 4 months,
Hmm.
and I was getting stipend, MTech stipend. So
Put it
I
to
set
good
up,
use. Yeah.
yeah, I set up lab in my
Hmm.
hometown.
Hmm.
Yeah, then it started. That was very messy lab.
Hmm.
I uh, I used my old table from in my
Hmm.
home.
Yeah.
Uh,
I bought Xbox with that money and I'm proud of it.
Priorities, right? Talk about priorities. Nice. But I want to learn everything about not everything. Basically, starting that would be my end goal. But starting of how does one go about designing a PCB. So I'm gonna catch you, Vivek,
Yeah,
sometime,
yeah,
and
sure.
I want to learn that. Yeah,
Yeah.
add that skill as
So first, first start using the zero PCB. Do you know zero PCB?
well. Raspberry Pi Zero, or
No,
that's
zero PCB.
no.
Zero
Okay.
PCB is like I have here this type of
Oh,
PCB.
okay,
It
okay.
has it has dot dot on
Dot.
it.
Okay, okay,
Hmm.
okay.
So start using this. From this means if you are
I see.
beginner, you
Begin.
will
It's a
get
hello world
some
of
confidence.
the PCB
PCB
Yeah,
world.
yeah. Yes, yes, yes.
Okay.
So what do you call breadboards? Minus PCB?
Yeah, yeah. It is. It is. One
That
stage
would
before
be
that.
what. There was a language designed by MIT, right? Scratch or something, where
Scratch.
you could plug in. So it would be that breadboards would be the Scratch of
Yeah, yeah.
PCB. Yeah.
Yeah. Then after doing this, you can go ahead for the PCB designing.
Hmm.
And previously, means when I was in college, I was using Eagle software, which
Mm-hmm.
is paid software. But
Okay.
for student, they give license.
Hmm.
Till I was in college, I was using Eagle, but after after graduating, for first, I was used to it. So Eagle, uh, I was not happy to shift to other software. So because I was using it since last 8 years, so I bought its subscription, and in 1 year I design only 2 3 PCBs.
Hmm.
So I decided to shift to open source software, that is KiCad.
Hmm.
Okay, yeah.
But the
So
more industry standard one is Altera, right?
yeah, yeah, Altera, but for hobbyist, KiCad is enough.
Okay. Altera is for much high speed
Yeah, yeah,
designs.
yeah, yeah.
Hmm.
Altera, then Altium,
LTM.
Altium.
LTM. It's LTM only, right? Why am I talking about Altera?
Altera is that Altera is
It was a
Intel's
company, right?
FPGA.
That
Yeah.
was the FPGA company.
Uh-huh.
Sorry, I got confused. It's LTM.
Yeah,
And I
Altera was
wanted
the
to speak
FPGA
up, but
company.
then I'm like, what would I know?
Yeah, it was LTM. Sorry, it's LTM. The
yeah,
industry standard tool is LTM.
yeah.
Hmm.
Mhm.
Yeah. Awesome. Awesome. I think with this we can wind up. Rajat,
Yeah.
you want to add anything? Yeah.
No, I think we will have Vivek in further
Future
videos.
podcast. Yes. Yes. Definitely,
Yes.
man. Definitely.
Yeah,
And
sure.
And
guys,
we will add Vivek's demo as well as YouTube channel in the
yeah,
description
in the
to
description. Yeah.
have a look at
Please
it.
do check out. Yeah.
Yeah.
Yeah,
Okay.
sure.
Okay.
Thanks. Thank you so much, Vivek, for joining our
Yeah,
session today and
yeah,
inspiring all of us here. Yeah.
yeah.
Thank you so
Thank you
much.
for inviting me.
Yeah.
No problem. Okay. See you
Yeah.
in the next one, folks. Bye bye.
Yeah.
Yeah,
Okay.
sure.
Bye.